All right, so the distance formula is basically a way to use your Pythagorean theorem, but with ordered pairs, with coordinates. So instead of A's, B's, and C's, you'll be using X's and Y's for those ordered pairs. So if we're looking at a grid, and we happen to have a couple of points, so maybe one point A is over here, and a point B is over here, and I wanted to know what's the distance between these 2 points. Well, when it's a diagonal line, you can't exactly count units. Remember, we can count units as they go up, we can count units as they go to the right, but we can't count units that are diagonal. But there is a formula that can do so. And the formula uses the idea of Pythagorean theorem, that even though this is not a triangle, can I create a triangle? Yeah. I could create a triangle by starting at point B. I could go up a certain amount, and then I could go to the right a certain amount, and I form a right triangle to where I find out what this measurement is and what this measurement is. Now, this measurement is just a measurement of the y's. So going from one y to the next y. So this is a distance of y's, and then this value is a distance for x, because it moves left and right. So if you know how far apart your y values are and how far apart your x values are, you could take those distances and then use them as values of a and b, which would be to square them, add them, and square root. Well, how can I find how far apart these y's are? What operation would find how far apart b and a are from each other? What operation do you think that is? Not addition. I wouldn't add the value of b and add the value of a together to get them. It would be what, Jayla? Subtraction. You need to find the difference or the distance between them. Distance and difference, they go hand in hand. So for here, the distance formula, we'll put it up here. Your distance formula, it follows suit with what our Pythagorean theorem is, right? Again, like I said before, you have to take the difference between your y's. Now, we call one of those points a y1 and a y2. Or, an x1 and a y1, and another point an x2 and a y2. So what we're doing here is we're first going to start with the x's. We're going to take one point of x, and we're going to find the difference using the other point of x. And then we square that difference. Then we add it with the second point for y minus the first point for y, and square that. So essentially this is like, oh, hey, when I take the difference of x and my two x's, there's my value of a, here's my value of b, I square those values, I add them, and then I take the square root. That's Pythagorean theorem used as a distance formula. So this is a formula that you're going to need to have memorized. You need to take this formula and memorize it. Of course we have examples. So let's say that we have the following point. We have point A is at 2, 3, and point C is at 6, 6. And I want to know what's the distance between A and C. So what is the measurement for line segment AC going to be? So again, you're not going to be able to plot it, but you can use your formula to be able to solve for it. So once again, our formula first needs us to label our points. Do you think it matters which one I label as my first and second? No, it does not matter. You will still get the same answer. The reason you get the same answer is because even though you are subtracting, and yes, 7 minus 2 and 2 minus 7 are not the same thing, But what is 7 minus 2? And what's 5 squared? 25. What's 2 minus 7? And what's negative 5 squared? 25. So because of the fact that you're squaring that difference, it doesn't matter the order that you subtract it in. It's going to eliminate that negative no matter what. Okay? So it does not matter which one of these points is your first or your second. Typically speaking, I just go ahead and label the first point I see as my first and the second point I see as my second. That's just what I usually do. But again, it could be in any order that I want, as long as whichever one I choose to be my second point stays my second point for the whole entire part of the problem. Now, the part that messes kids up a lot is when there happen to be negatives. We don't have negatives for this problem, but you need to keep in mind that everything I'm going to write down right now is always going to be consistent here. Everything I'm writing in this purple is already just pre-written. That's pre-part of the problem, and now all I have to do is fill in the numbers. So if I have to subtract a negative, I still have to write that negative there. A big problem that students make is that they see that they have a negative, and they're like, oh, I already wrote subtraction. I don't have to write the negative. Well, then that messes up that answer completely. If you've got a problem that's 6 minus negative 2, which is supposed to be 8, but you only put 6 minus 2 and you get 4, that makes a huge difference. So you need to be mindful that a subtraction sign is going to be constant no matter what. The negative sign has to be placed if the problem has a negative in it. Okay? All right. So again, the components. I'm going to take x2 minus x1. What's my x2 value? 6. What's my x1 value? 2. Here's my x2. Here's my x1. So I have 6 minus 2. Now we're going to do it for y2 minus y1. What's my y2 value? 6, right there. And my y1 value? 3. Again, it doesn't matter. I could do 2 minus 6 and 3 minus 6. I'd still be able to get the same answer once I've squared them. Okay? Now you do have to go in the order of operations. What do we have to complete first? Parentheses. We have to complete the parentheses component first. So we have to do the subtraction part first, which means everything in here is still going to stay the same. I'm still going to have a square root. I'm still going to get some value that's squared plus another value that's squared. But now I'm going to go ahead and subtract them. What's 6 minus 2? 4. What's 6 minus 3? 3. Okay, so now I have the square root of 4 squared plus 3 squared. What's the next thing that I need to do? Connor? I need to square them. I need to actually square these numbers. So now I'm going to square these values here. So now I've got D is equal to the square root of, what's 4 squared? 16. What's 3 squared? 9. Okay. Now, do I square root first or add first? Add. You add first. You have to add first. Remember, you can only take the square root of a single number, not a problem. So now we get D is equal to the square root of 25. And what's the square root of 25? 5. So the value of the line segment is 5 units. All right, let's try another one. Okay, point A is at negative 2, negative 7. Point B is at negative 7, 5. And I want to know the measurement of the line segment. Line segment AB. So again, everything that's part of the problem, that's what I typically like to do. I like to tell you guys ahead of time, just write in everything that you know is supposed to be there before we start adding in the numbers. I know there's a square root. I know that there's going to be an addition. I know that there's going to be a subtraction problem on either side of that addition. And I know that each of those subtraction problems is then going to be squared. So I like to put those components in ahead of time, and then I start filling in my numbers. Because again, I know that that subtraction sign needs to be there ahead of time, and it shouldn't be mistaken with a negative. Does it matter which one of these is my first or second point? No. Okay, so again, I'm just going to go ahead and label this x1, y1. I'm going to label this one x2 and y2. So the order that I tell you to do it would be x2 minus x1. So what's my x2 value? -7. Based off of what I assigned, my x2 is -7. What is my x1? -2. So I have to write a -2. Yes, it's going to say minus a -2, and that's okay. What's my y2? 5. What's my y1? -7. So again, 5 minus -7. Now that we have it all in there, we follow our order of operations. Again, the first thing we do is the subtraction inside these parentheses. So I get the square root of what's -7 minus -2? -5. What's 5 minus -7? 12. So now I have -5 squared plus 12 squared, all of it inside the square root. The next thing that we're going to do is take those square roots. So we now have d is equal, I'm sorry, not square roots, take those squares, those exponents. We now have the square root of, what's -5 to the second power? Positive 25. A negative times a negative is a positive. Plus, what's 12 to the second power? 144. Okay, the last thing that we do is we combine these together. What's 25 plus 144? 169. Okay, and then what is the square root of 169? 13. So the distance between the point A and point B is 13 units. Okay, I'm going to have you guys try a couple of them on your own. You are going to get decimal answers for a couple of them. You need to round it to the nearest tenth. Round to the nearest tenth for those decimal ones. Okay? 1 decimal place. All right, I'm going to switch to the next page. Is that okay? That way it mirrors. Good? All right. go over it. Who can tell me what they got for problem 3? What was the distance between A and C? Kinston? Okay, so you can't have a negative for your distance because you can't take a square root and get a negative number. Elisa? 10. So let's go over and take a look at it. So we'll let this be our x1, y1. This will be our x2, y2. Remember, for our formula, it's always going to be the square root. We're going to have a subtraction that's squared and another subtraction problem that's squared. It's going to be our x2 value, which is 7, minus our x1 value, which is 1. Our y2 value, which is 1, minus our y1 value, which is 9. The first thing that we're going to do is subtract these values. So that's going to give us the square root of 6 squared plus a negative 8 squared. Then we're going to go ahead and square these values. So that now gives us the square root of 36 plus 64. It's a positive 64 because a negative times a negative becomes a positive. Then we add these values together. That's going to give us the square root of 100, and the square root of 100 is just 10. Okay, what about for problem 4? No way. What did you get for number 4? Huh? Not 1.8. Diego? Not 0.5. So some of you are messing up with those negatives again. Valina? 4.6. 4.6. Okay. X1, Y1, X2, Y2. So those of you who are getting it wrong, make sure you're paying close attention so you can figure out what it is that you did wrong. It helps, again, if you preset the problem up, so that way all you're doing is filling in the points. So x2 is a negative 1.5 minus an x1, so minus 1.5. Then your y2 is also a negative 1.5 minus your y1 value, so minus a 2. So the first thing that we need to do is that subtraction. Those of you sometimes think you know your subtractions. You might not know them as well as you think. So when we take the difference between negative 1.5 and 1.5, that's going to give you a negative 3. And then negative 1.5 minus the 2 is going to give you a negative 3.5. The next thing that you need to do is square these values. So that now gives you the square root of negative 3 to the second power is 9. Negative 3.5 to the second power is 12.25. 12.25. Okay, so then you're going to go ahead and combine those together. That gives you the square root of 21.25. And the square root of 21.25 is approximately 4.6. Okay, let's talk about the last one. What did you get for the last one, Justin? 8.2. 8.2. Okay. X1, Y1. X2, Y2. Again, pre-fill so that way you're not messing up. It helps sometimes if you pre-set it. So we're going to do negative 3 minus 5. And then a negative 2 minus a negative 4. Okay, we now need to go ahead and subtract negative 3 minus 5 and negative 2 minus negative 4. Negative 3 minus 5 gives you a negative 8, so you now have negative 8 squared. Negative 2 minus a negative 4 gives you a positive 2, so now you have positive 2 squared. The next thing you do is to square those values. So you're going to get D is equal to the square root of 64 and 4. Then you need to actually add those numbers together. What's 64 plus 4? 68. So you now have the square root of 68, and the square root of 68 is approximately 8.2. Okay? That's what you're doing for your homework tonight, guys. Any questions? That's fantastic. I'm so excited that you're going to Jekyll. You still have your homework tonight. You'll turn it in on Monday. Now,